Okay, this circuit is similar, but now you have a capacitor here. So the charging and discharging of this is what we're interested in. But first, it asks us to find the equivalent resistance of these three resistors. Pretty much the same thing we just did in the other quiz. So adding these together is easy. Adding these is just simply adding them since it's in series. So this is also 400 just like before. And then now that I know that these two act like a 400 ohm resistor, I can add it in parallel with 800. But to do that, I have to do the 1 over R business. So 1 over 800, 1 over 400. Equals 0.00375. But then to do this, to find the actual resistance, I do 1 over that number. And on the calculator, you can just do 1 divided by answer. So it's about 267 ohms. So this entire circuit looks something like this, where all those resistors have an effective resistance of 267. So find the function VR of t that gives the voltage applied to the resistor at time t. Notice VR of t, VC of t, it can be confusing. The general formula for each one of these looks something like this, and this one looks like P1 minus e to the kt. And then you also need to know that k is the time constant. Well, it's not the time constant, it's -1 over the time constant. So let's go ahead and find out what this number is, because I need it for both. -1 over R, which is 267. Capacitance is 100 millifarads, so it's 100 times 10 to the milli times 10 to the -3. It's like millimeters. Move it over 3. So instead of writing 10 to the -3, I'm going to literally move over the decimal to here. See that? So this is now 0.1. And that equals -1 divided by 267 times 0.1. So whatever this number is, I'm going to store this in K, just so I don't have to type in all those numbers again. So now each one of these equations becomes P is the original voltage. So what would the original voltage be here? Would be 12 e to the, and in this case it's about -0.037 t. And over here, Vc of t, 12.1 minus e to the -0.37 t also. So both equations very, very similar. Okay, now it's asking us to find the time constant. Time constant is just R times C. So that's going to give us 267 times 0.100. $26.7. Now, what that's supposed to mean, time constant, this is in seconds, this is how long it will take, to charge up to, I think it was about 69%. Forget the exact number, about 69%. Okay, so moving on. Oh, time it takes to charge the capacitor to about 69%, or it's like 68 or 67, something like that, ish, of the total voltage. Okay, moving on. VC of 60, that means I'm going to plug in 60 into this equation. 1 minus e to the negative 0.037 times 60. So plug it all in. Make sure to put parentheses around that number. I'm going to be able to take the shortcut of just plugging in K times 60. It's about 10.7, and the meaning of this means that after 60 seconds or a minute, the capacitor will be charged to 10.7 volts. Then the last one, if you discharge the capacitor, how long will it take to charge the capacitor to 6 volts? So it's the same thing, I just wanted you to understand that it starts off charged at 0. So when will, you're basically asking when does VC of 60 equal 6? That's the question. So you set 12, all this to the t, which you don't know, set it equal to 6, and solve. I'm going to set this equation in here, 1 minus e, that was Rachel making funny noises, times it was her. And I'm going to change the window from 0 to, notice it was already at 10 volts after a minute, so I don't need to really go past a minute. And then the voltage goes from 0 up to 12 max, because that's it. And so it should look, it starts to charge, and then it levels off, because it's not going to go past 12. Okay? No, like an exponential function. Okay, so when will it equal 6? It should be right there, so just super trace, find the intersection. So voltage will be 6 at about 18.5 seconds. So T equals 18.5 seconds.